Okay, so we're going to do a little bit of review of implicit differentiation, which is perfect because that's going to lead right into what we're doing today. Today we're going to cover related rates. This is the last of the new material before the test. So this will kind of wrap it up. People want to look at number 29 and 47, which both have lens. So let's just do one and see how we're doing. Right, so here is 29. X and then y plus 2y equals 2x cubed. And the instructions say to find y prime and evaluate it at the point 1, 1. Okay, so the first question is, I'm trying to find y prime. Can I solve this for y?
No.
No, because there's no way to combine these two. They're not like terms. There's no way. I can't factor. There's nothing to do. So I can't solve for y, so I can't just solve for y and then find y prime like we normally do. That means this is implicitly defined, and we have to use implicit differentiation to do that. So the process we're going to go through, we're trying to find y prime. What's another way to write y prime? dy dx. So that tells us what we're doing. We want to find this. That's our instruction. Do the derivative with respect to x. We're going to do that for the entire equation, both sides. So let's just write that out. d dx x ln y plus 2y equals 2x cubed. So that's the first step, is to d dx, take the derivative with respect to x of the entire equation. Now we need to decide if we have, we're going to take these one at a time, one piece at a time, and decide what kind they are. Let's start with this one. This is easy. This is a basic. Everyone agrees this one's an easy one to do. All right, so we'll leave that to the end. What about 2y? Is that a basic?
No.
Not quite. I mean, it is. It's just the wrong variable. So that means the derivative is easy, but I have to remember to tack on the derivative of the inside, the dy dx. So we'll come back to that one. So very easy, mostly easy. What is this one? And what I suggest that you do is use your English skills and start reading the sentence, plugging in all of the English. I know that sounds sort of silly. X times ln of y. So x times ln of y. This tells you, when you say the word times, that tells you product rule. Product rule. And whenever you say of, what follows will be the inside. So when I see the word of, I know this is the inside, and this is the outside. So I know I have a chain rule to do. So ln of y. Ln of x is a basic, right? If my inside is just x, that's just a basic. That's no problem. But this is ln of y. So I know I'm going to have to use a dy dx on that one. Okay, so really, I read with English, and it will help you find it. Okay, so times means product of, square root of, what follows is the inside. Ln of, what follows is the inside. Another one that shows the inside is coming is when I say e to the, what follows is the inside. Okay, so there's some key words that if you actually read it in English, and the same thing I do when I'm doing product rule or quotient rule, I'm saying the words in my head. First times derivative of the second. I do that. How long have I been doing this? A really, really long time. So I encourage you to kind of give yourself instructions as you go. Okay, so let's go ahead and do that. So now we know we have a product rule here. So we're going to take these one at a time. If it helps you, go ahead and label these first and second. Remember, we have two pieces of the product rule. I find what troubles most people is they'll go through a complicated first piece and feel like they're done because they've done so much work. And I get that, but just make sure that you keep track of your two pieces. All right, so we have first times derivative of the second. So the derivative with respect to x, derivative of a ln is 1 over whatever the inside is. You gotta keep, you don't change the inside until you get to the inside. So 1 over is the derivative of ln times derivative of the inside, dy dx or y prime. You can write either one. Am I done with the product rule? No, this is just the first term. So now I need to add the second, and then y times the derivative of the first. It's just 1. Okay, so now I'm done with the product rule. So all of this right here is just taking the derivative of that first term. Okay, so let's move on to the next one. Plus 2y. That's just 2y prime. Is everyone comfortable with that? And then equals 6x squared. Okay, so the first step in doing implicit differentiation is to take the derivative with respect to x of the entire equation, and then pay attention. You're going to have combinations of products and chains, and usually not quotients that get too ugly. Okay, so now what do we need to do? The whole point of this was to find dy dx. And it's okay to write yourself notes on the side to help keep track of where you are in the process. So we've done this step. Now we need to collect all of our y primes on one side. Okay, so everything with a y prime I'm going to leave here, and everything else I'm going to put there. If it helps you to clean this up first, that's not a bad idea. So we can write x over y, y prime. That's a little cleaner, and it's less to then feel like you have to manipulate. So I encourage you to do this step, ln y plus 2y prime equals 6x squared. So it's just a little bit cleaner, and I find that it feels like there are not so many pieces. So everything with y prime stays here. So x over y, y prime plus 2y prime. This does not, so it goes on the other side. Okay, so now we need to figure out sort of how many y primes we have. We also have a fraction. So there are a couple of options here. One is to just keep going along the path and factoring out the y prime. That's the next thing we're going to do. Or the other thing we could do, having this fraction is going to be a problem eventually. So the other thing you can do is multiply the entire equation by y. That will clear the fraction immediately. So I recommend doing it at this step, or there's another step at which you could do it later. So either one. So one option here, I think, is to go ahead and multiply by y. Remembering that that's this one, and this one, and this one, right? You have to multiply all the terms by y individually. So if I multiply this one by y, the whole point of that was to cancel out the y in the denominator, plus, and I usually write all my y primes at the end. That's, I don't know, just I guess a habit, but also it makes it easy. Then all your y primes are kind of in the same location within each term, and so it's a little bit easier to see how they factor. 6x squared y, we usually write x before y because we like to be alphabetical, and we always write polynomials before limbs. And remember, we came up with that, so that's the order you want to write things in. Coefficients, polynomials, exponentials, logs. Okay, so now we're ready to factor out a y prime. It's a little bit easier to see. So we've collected all our y primes. The next thing we're going to do is factor out the y prime. Another way of thinking of this is saying, how many y primes do I have? Well, I've got x of them from this term, and 2y more of them from this term. So you can either think of literally factoring out or sort of counting up. They really mean the same thing. So when I factor out, that's dividing and seeing what's left. So x is left here, 2y is left here, and then I just keep right down. And then the other thing, I think I've introduced you to this notation. Every once in a while, you keep working with one side and working and working and working. Instead of writing down the other side over and over and over again, you can write RHS, right-hand side. You might guess what LHS is, left-hand side, right? So that's just, and mathematicians know that shortcut, so that's okay. All right, so now what do? We have factored out the y prime. Now we just need to divide by this. All right, so now we're just going to divide, solve for. Your answer will have y's in it, totally okay. So here we'll have y prime equals, now you really do need to write it out, 6x squared y minus y ln y all over x plus 2y. With lns, you will have fractions, because as soon as you take the derivative of a ln, you have 1 over the inside. So you will have fractions, so you will have to clear fractions. So this is a good place to do it. If you had not done it here, you would have had a fraction here, x over y still. You would have ended up with a fraction down here, x over y still. And then you can just multiply top and bottom by y to clear the fraction there. So there are two good places to do it, and it really doesn't matter which. I kind of like doing it here just because sometimes I think the quicker we get out of fractions, the fewer mistakes we make. Okay, so are we done? No. We've gotten y prime, but we didn't evaluate it at this point, so let's do that. Remembering, let me remind you of a few things. ln of 1 is
0.
0. How do I remember that? If you're not sure, most people remember this one, that's an exponential. We know that anything to the 0 is 1. We know that goes through there. So a lot of people will remember this one. The ln, remember, is just reflected. So ln of 1 goes through 0. So that's the pair. What is this one, ln of e?
10.
No. Anyone know this one?
1.
Yeah. You can think of it putting it a 1 there. If you wanted to, ln's undo e's, leaving just the exponent. So if you had ln of e squared, that would be 2. So these two are good to kind of have in your back pocket so you know what they are, because when it comes to, usually when we have ln's, we use e's and 1's because they're easy to evaluate. So if I put in 1, 1 here, I'll get 6 minus 1 times 0 over, so I'll get 6 minus 0 over 3, so 2. And remember the notation, I was very sloppy. Remember the notation we used? We used that line, the evaluation line, at 1, 1. It's one of the things I like about grading your assignments by hand is that I feel like I can go in and kind of fix up some of the way you write things, because one of the important things is that if you write out correctly and label things, particularly I encourage you to label f of x and f prime of x, and starting next week, f double prime of x. If you label them, okay, it's going to be easier to keep track of what each piece tells you, because we learn some information from here, and some from here, and some from here. And if you've not labeled them well, you're not maybe going to find what you need when you go back. So is this better? Ln's are a pain? But, so let's process again. So the idea is, if I cannot solve for y, I have to do implicit. I have no choice. So I'm trying to find dy dx. That tells me what to do. d dx, the whole thing. This is a verb. It says take the derivative with respect to x. This is a noun. It says this is the derivative of y with respect to x. Go through being careful to do chains and products in whatever order you need to, and then collect all your y primes on one side, factor out y prime, and then solve for y prime. Is this a good time to do the minute to win it, which covers exactly this, what I just said? Can you put that in?